So, problem number 1. If 𝗑𝗧𝗃 and P4K and Q23 are conjugate points. With respect to the circle, S is equal to x square plus y square minus 17 is equal to 0, then K equals number 1, 2, 3, 4 and 4, 5. Okay? Right. Now, the solution is simply conjugate points means the polar of one of the points passes through the other. Through the other point. Now, polar of Q23 with respect to S is equal to x square plus y square minus 17 equal to 0 is by the formula S1 is equal to 4x plus 2x plus 3y minus 17 is equal to 0. Now, by hypothesis, this passes through P4K, implies 2 into 4 plus 3K minus 17 is equal to 0. So, therefore, 3K is equal to 9 or K is equal to 3. So, therefore, correct answer is option number 2. Correct answer is option number 2 itself. So, here the conjugate points means conjugate points or conjugate lines means conjugate point means the polar of one lies on the polar of one passes through the other. Conjugate lines means the pole of one lies on the other line. Proceeding to the next problem, just I will explain what is meant by inverse points. Inverse points with respect to a given circle. Just explanation, concept of inverse points. So, you are given a circle with center C and radius R. See, this is, let C be a circle with center C and radius R itself. Now, 2 points P and Q lying on a line through the center C, and on the same side of C, such that CP into CQ is equal to R square, radius square, then P and Q are said to be inverse points with respect to the circle C. For inverse points, the 2 points must be lie on the same side of the center on a line passing through the center, with the property that the distance from C, the distance of those points P and Q from center, the product must be equal to the radius square. Then we call it as P and Q are called inverse points with respect to the given circle. And obviously, you can have that is here. And here note is the inverse of Q or inverse of P is nothing but the intersection of the line CP and the polar of P. Also, you might have studied in your intermediate. Also, the inverse of P with respect to circle is nothing but foot of the perpendicular drawn from P onto the polar of P, itself. Now we will go to the problem number 2. The inverse of P minus 2, 3 with respect to the circle S is equal to x square plus y square minus 4x minus 6y plus 9 equal to 0 is 1, 3, 1, 2, minus 3, 1, 3, 3, minus 1, and 4, 1, 3. 1, 3 itself. Right. The solution, as I told you before, the inverse Q of P with respect to S is equal to 0 is the intersection of the line CP and the polar of P, where C is the center. Right. Now, by hypothesis, center C is equal to the point 2, 3. Center C is equal to 2, 3, and radius is square root of 4 plus 9 minus 9 is equal to 2. Now equation of the line CP is y minus 3 is equal to 3 minus 3 by 2 plus 2 into x minus 2, which is 0. So therefore, y is equal to 3. Y is equal to 3 is the equation of the line CP. Now equation of the polar of P is equal to P minus 2, 3 is x into minus 2 plus y into 3 minus 2 into x minus 2 minus 3 into y plus 3 plus 9 is equal to 0, or that is minus 2x minus 4x. Next, plus 3y minus 3y will cancel. Plus 4 plus 9 plus 4 plus 9, 13 minus 9. So what you get is minus 4x is equal to minus 4, or x is equal to 1. X is equal to 1. So therefore, from 1 and 2, the inverse Q of P minus 2 comma 3 is equal to 1 comma 3 is equal to x is equal to 1 and y is equal to 3. 1 comma 3. So that means the correct option is option number 4. Option number 4 itself. Pole of the line x minus 2y plus 22 equal to 0 with respect to the circle. S is equal to x square plus y square minus 5x plus 8y plus 6 equal to 0 is 1, 2 comma 3, 2 minus 2 comma 3, 3, 2 comma minus 3, and 4 minus 2 comma minus 3. Now, to find the pole of the given line with respect to circle, the usual procedure is simply, we know the equation of the polar of a point x1, y1 is s1 equal to 0. But by a hypothesis, this is the polar of the point x1, y1. So you will simply equate that the corresponding coefficients are proportional. From that you will get the value of x1 and y1. So now you can take that is let Px1, y1 be the pole of the line, L is equal to x minus 2y plus 22 equal to 0. That is, L equal to 0 is the polar of Px1, y1. But polar of Px1, y1 with respect to the circle S is equal to 0 is S1 is equal to xx1 plus yy1 minus 5 by 2 into x plus x1 plus 4 into y plus y1 plus 4 into y plus y1 plus 6 is equal to 0. Or that is 2x1 minus 5 into x plus 2y1 plus 4 into y, 2y1 plus 4 into y, and minus 5x1 plus 4y1 plus 6 equal to 0. On simplification this is. So that is S1 equal to 0 and L equal to 0 represent the same line which is the polar of P, Therefore, the corresponding coefficients are proportional. So, therefore, 2x1 minus 5 by 1 and is equal to 2y1 plus 4 by minus 2 is equal to minus 5x1 plus 4y1 plus 6 by 22. So, this is by 8. So, from this what you get is, so that implies x1 is equal to lambda plus 5, x1 is equal to lambda plus 5 by 2 and y1 is equal to minus 8 minus 2 lambda by 2 and minus 5x1, that is minus 5 into x1 means lambda plus 5 by 2, y1 plus 4y1 means minus 8 minus 2 lambda by 2 plus 6 is equal to 22 lambda, is equal to 22, not plus 12, plus 12 is equal to 22 lambda. So, that indicates on simplification, you can write on simplification we have the value, we have lambda is equal to minus 1, we have lambda is equal to minus 1. So, therefore, x1 is equal to minus 1 plus 5 by 2 which is equal to 2 and y1 is equal to minus 8 plus 2 by 2 which is equal to minus 3, which is equal to minus 3 itself. So, the correct option is 2 minus 3. So, correct option answer is option number 3, 2 comma minus 3. x1 is equal to 2, y1 is equal to minus 3. The locus of the midpoints, this is good problem. The locus of the midpoints of the chords of contact drawn from the points on the line x plus y plus 4 equal to 0 to the circle S is equal to x square plus y square minus 4 equal to 0 is 1. X square plus y square plus a square into x plus y is equal to 0. 2. 2 into x square plus y square plus a square into x plus y equal to 0. 3. 3 into x square plus y square plus 2a square into x plus y is equal to 0. And lastly, 4 is 4 into x square plus y square plus a square into x plus y is equal to 0. Right? So, now the problem, if you draw that diagram, you are given a circle and a line x plus y plus 4 equal to 0. From this, from the points on the line is drawing tangents to the circle and joining the points of contact. Joining the points of contact, which is called AB, which is called the chord of contact. Now, he is asking the midpoint, the locus of the midpoint of these chords of contact. That means, if P varies on the line, the chord of contact varies. So, the midpoint varies. So, therefore, we want to find the equation which is satisfied with all these midpoints of the chords of contact. So, S is equal to x square plus y square minus a square equal to 0. Let 𝗵𝗫𝗃 be a point on the line x plus y plus 4 equal to 0. So, therefore, h plus k plus 4 is equal to 0. Reference number 1. Now, we know that the chord of contact of 𝗵𝗫𝗃 with respect to S is equal to 0 is S1 means Hx plus Ky minus a square is equal to 0. So, this is number 2. Now, let mx1y1 be the midpoint of the chord of contact AB of 𝗵𝗫𝗃 AB of 𝗵𝗫𝗃. So, therefore, equation of the chord in terms of its midpoint, mx1y1 is S1 is equal to S11 or xx1 plus yy1 is equal to x1 square plus y1 square. Okay, right. Now, equation reference number 3. Now, the thing is, so that is 2 and 3 represent the same line the same line AB, which is chord of contact, AB, which is the chord of contact. Right? So therefore, the corresponding coefficients are proportional. Therefore, the corresponding coefficients are proportional. So therefore, h by x1 is equal to k by y1 is equal to x1 square plus y1 square by a square. X1 square plus y1 square by a square. So suppose each is equal to lambda, say. Each is equal to lambda, say. So therefore, h is equal to lambda x1, k is equal to lambda y1, and lambda square into x1 square plus y1 square is equal to a square lambda. A square lambda. So therefore, lambda is equal to a square by x1 square plus y1 square. A square by x1 square plus y1 square. Lambda, lambda will cancel. So therefore, now substitute this value. So therefore, h is equal to lambda x1 is not. So a square x1 by x1 square plus y1 square, and k is equal to a square y1 by x1 square plus y1 square. Now substitute these values of h and k in reference number 2. Now substituting these values of h and k, in 1, we have a square x1 by x1 square plus y1 square plus a square y1 by x1 square plus y1 square plus 4 is equal to 0. H plus k plus 4, reference number 1. Reference number 1 is h plus k plus 4. So in that, substitute the values of h and k. So that indicates that a square into x1 plus y1 plus 4 into x1 square plus y1 square is equal to 0. So therefore, locus of mx1 y1 is 4 into x square plus y square plus a square into x plus y is equal to 0. So that is the locus of the point mx1 y1. So the correct option is 4. So correct answer is option number 4. 4 into x square plus y square plus a square into x plus y is equal to 0. The locus of the point whose polars with respect to the circles, whose polars with respect to circles, S is equal to x square plus y square minus 4x minus 4y minus 8 equal to 0, and S dash is equal to x square plus y square minus 2x plus 6y minus 2 equal to 0 are at right angles. are at right angles is number 1 x square plus y square minus 3x plus y minus 2 equal to 0. Number 2 x square plus y square minus 3x plus y minus 4 equal to 0. 3 x square plus y square plus 4x minus 2y minus 2 equal to 0. 4 x square plus y square minus 3x minus y minus 4 equal to 0. The problem is here, see, you are given two circles. Now, he asked the locus of all those points from which the polars, whose polars with respect to the two circles, they must intersect orthogonally. That is, they must be perpendicular to each other. If the polars of a point with respect to two circles are at right angles, then what is the equation of the curve satisfied by that point? (90 degrees). That's point P. We want the locus of the point P itself. So, S is equal to 0, S dash is equal to 0. Now, let P x1 y1 be a point such that the polars of P with respect to the circles S is equal to 0 and S dash is equal to 0 are at right angles. Are at right angles. So, now the polars of P are nothing but S is equal to 0, S dash equal to 0. X1 plus y by 1 minus 2 into x plus x1 minus 2 into y plus y1 plus 8 equal to 0, or x1 minus 2 into x, y1 minus 2 into y, minus 2x1 minus 2y1 plus 8 equal to 0. Number 1, this is S1, and S dashed 1 is equal to xx1 plus y by 1 minus of x plus x1 plus 3 into y plus y1 minus 2 equal to 0, or that is x1 minus 1 into x plus y1 plus 3 into y minus x1 plus 3y1 minus 2 equal to 0. 2. Number 2. Now, by hypothesis, now the lines 1 and 2 are at right angles, if and only if the product of their slopes is equal to minus 1. So, that is if and only if the product of their slopes means minus of x1 minus 2 by y1 minus 2 into x1 minus 1 by y1 plus 3 is equal to minus 1, or that is if and only if. So minus minus will cancel. x1 minus 2 into x1 minus 1 plus y1 minus 2 plus y1 minus 2 y1 minus 2 into y1 plus 3 is equal to 1. So that is if and only if x1 square plus y1 square minus 3x1, 3y1 minus 2y1 plus y1, so minus 6 plus 2, minus 6 plus 4 plus 2, say minus plus 2 minus 6. So what you will minus 4 minus 1. So you will get 2 minus 6 minus 1. So minus 5 is equal to 0. Is equal to 0. So you will get minus cancel. So minus 6 plus 2 minus 4 is equal to 0. So therefore, the locus is x square plus y square minus 3x plus y minus 4 equal to 0. Now you will see which is the correct option, right? Option number 2, the correct answer is option number 2, x square plus y square minus 3x plus y minus 4 is equal to 0. So correct option answer is option number 2. Now we are taking up the problem number 6. This is a good problem, of course. This is a good problem. Let SB is equal to, of course, this is a good problem, especially for EAPCET and mains, but not for advanced. 𝗧 is equal to x square plus y square minus c square equal to 0, where A is greater than B greater than C. A greater than B greater than C. Now, if the polar or chord of contact, I am writing, both are same, the problem is true. We are given polar or chord of contact of any point on S is equal to 0 with respect to S dash equal to 0 touches S double dash is equal to 0, then A, B, C are in 1. Arithmetic progression, 2. Geometric progression, 3. Harmonic progression, and 4. Arithmetic or geometric progression, AGP. AGP. So that means you are given C and the circle. Now he is taking any point P on this and chord of contact or polar, whatever may be the. That is, it touches the circle. So this is outermost circle and this is second circle and this will be the third circle. Okay. Now you can see that let Px1, y1 be a point on S is equal to 0. So therefore, x1 square plus y1 square is equal to a square, number 1. Now, the polar S1 is equal to xx1 plus y1 minus b square is equal to 0 with respect to polar S1 of p with respect to s dash equal to 0 touches s double dash is equal to 0. So, that is if and only if 0 into x1 plus 0 into y1 minus b square by square root of x1 square plus y1 square must be equal to the radius. Radius means c. Radius of the circle s double dash equal to 0. So, that means, that is if and only if b square is equal to c into root over x1 square plus y1 square. So, that is c into a by reference number 1, because reference number 1, what it is, x1 square plus y1 square is equal to a square. So, root over x1 square plus y1 square is equal to a. So, b square is equal to ca. So, that implies a, b, c are in GP, geometric progression, are in a GP, geometric progression. So, answer is option 2. Answer is option 2 itself. The internal center of similitudes of the circles S is equal to x square plus y square plus 6x minus 2y plus 1 equal to 0, and s dash is equal to x square plus y square minus 2x minus 6y plus 9 equal to 0 is 1. 0 comma 5 by 2, 2, 5 by 2 comma 0 and 3, 0 comma 5 and 4, 5 comma 0. And all of you know that the internal center of similitude of two given circles is nothing but the point of intersection of the transverse common tangents which intersect on the line joining the centers. Okay, and the internal center of similitude divides the line joining the centers in the ratio of their radii. Now you can see that is A is equal to minus 3 comma 1 and R1 is equal to square root of 9 plus 1 minus 1, which is equal to 3, and B is equal to 1 comma 3 and R2 is equal to square root of 1 plus 9 minus 9 is equal to 1. So this is a bigger circle and a smaller circle. So this is A, this is B. And you know that transverse common tangents, they meet on generally, actually of course here I have used S and S dash, but the centers of similitude they usually written denoted by S and S dash. S and S dash. Suppose this is P is the, so A is equal to, the center is -3, -1, and B is 1, 3, and radius 3 and 1. So the internal, let P be the internal center of similitude, be the internal center of similitude. So therefore, P divides the line joining the centers line joining the, P divides the line joining the centers in the ratio of 3:1, in the ratio 3:1 internally. So that means, now you can write that is, so therefore, P is equal to 3 × 1, 3 × 1 plus 1 × -3 by 4, and 3 × 3, 3 × 3, 3 × 3 plus 1 × 1 by 4. So that is simply 0, 10 by 4 means 5 by 2. 5 by 2 itself. So the correct option is 0, 5 by 2. First option. So correct answer is simply option number 1. And here see, I am telling you, if two circles do not have a common point of intersection, then those two circles will have 4 common tangents. 2 are direct and 2 are transverse. The transverse common tangents, they divide the line joining the centers internally in the ratio of their radii. And the 2 direct common tangents, they intersect on the line joining but at the point which divide the line joining centers externally in the same ratio, externally in the same ratio. That means external center will divide these simply in the ratio of 3:1, 3:1. That is external center of similitude. The external center of similitude of the circles S is equal to x² plus y² minus 4 equal to 0, and S dash is equal to x² plus y² minus 2x minus 6y plus 9 equal to 0 is 1, 2, minus 6, 2, minus 2, 6, 3, minus 2, minus 6, and 4, 2, 6, 2, 6. And as I told you, now we'd rather write the centers and radii. O is equal to 0, 0, and R1 is equal to 2, and A is equal to 1, 3, and R2 is equal to 1. R2 is equal to 1. Are the centers and radii of the circles. Now you can have that is So, that is the line joining the centers. And OA is equal to 1, this is 2, R1 is equal to 2. So, the center of external center of similitude means the point at which the direct common tangents meet. That is. So, this is, let Q be the external center of similitude. So, this is 0, 0 and this is 1, 3. 1, 3. So, Q divides. So, therefore, Q divides OA in the ratio 2:-1. 2:-1. So, you can have that is OA 2:-1. Now, so therefore, Q is equal to 2 into 1 and minus 1 into 0 plus minus 1 into 0 by 2 minus 1 and 2 into 3 plus minus 1 into 0 by 2 minus 1. So, which is nothing but 2, 6. 2, 6, yes, sir. 2 minus 1, it is 1. So, 2, 6 by 1, 6. So, that is the external center of similitude. So, the correct option is option number 4. Option number 4. So, the thing is internal center and external center, they divide the line joining centers in the same ratio, but internal center, internally, external center, external division. If the lines x plus y minus 5 equal to 0 and 2x plus ky minus 8 equal to 0 are conjugate with respect to the circles S is equal to x square plus y square minus 2x minus 2y minus 1 equal to 0, then the value of k, options 2, minus 2, 3, minus 3. Now, the solution is, let Px1, y1 be the pole of L is equal to x plus y minus 5 equal to 0 with respect to S is equal to 0. So, therefore, polar of S is equal to 0, polar of Px1, y1 with respect to S is equal to 0 is xx1, s1 is equal to xx1 plus yy1 minus of x plus x1 minus of y plus y1 minus 1 equal to 0, or that is x1 minus 1 into x plus y1 minus 1 into y, okay, and minus of x1 plus y1 plus 1 equal to 0. So, therefore, this is the polar of the point x1, but by hypothesis, the polar of point x1, y1 is L equal to 0. So, therefore, the corresponding coefficients are proportional. y1 minus 1 by 1 is equal to minus of x1 plus y1, x1 plus y1 by minus 5, y1 by minus 5, x1 minus x1 by 1, y1 minus 1 by 1 and minus of x1 plus y1 plus 1 by minus 5. So, now each is equal to say. So, this implies x1 is equal to 1 plus lambda, y1 is equal to 1 plus lambda and 1 plus lambda plus 1 plus lambda plus 1 is equal to 5 lambda, or that is 2 lambda, 3 lambda is equal to 3, or lambda is equal to 1. Now since lambda is equal to 1, so therefore Px1 y1 is simply 1 plus lambda, 1 plus lambda, which is equal to 2 comma 2. Now by hypothesis, 2x plus ky minus 8 equal to 0 passes through 2 comma 2. So therefore 2 into 2 plus k into 2 minus 8 is equal to 0. So 2k is equal to, so 4, 2k is equal to 4, or k is equal to 2. K is equal to 2. So therefore the value of k is, the correct option is 1 comma 2.